For problem 6.2, you're supposed to plot the data on a scatter plot. To do this, you must construct a graph with consistent units. The data table is right here. For this particular problem, the units of the graph would be 1, 2, 3, 4, and 5, and negative 1, 2, 3, 4, and 5 on both the x-axis and the y-axis. So next, you're supposed to plot the data. So the first point would be negative 5, 0. So you go over on the x-axis left 5 units, so 1, 2, 3, 4, 5, and up 0, so you just plot it right there. The next one is negative 3, 4, so you go over to the left 3 and up 4. The next is 0, 5, so you don't go over left or right on the x-axis and up 5. For this one, it's 0, 5, so you don't go left or right on the x-axis, and you go up. What the heck? So it'd be right here, and then the next one is 3, 4, so you go over 3 and up 4 on the next side, and the last one's 5, 0, so you go over 5 to the right on the x-axis and up 0. So your graph should look like that. On most graphs, you got to remember that you're supposed to label your x-axis with units and your y-axis and include a title, but for this particular problem, there's no exact units for the data. It's just a table they give you. So to find the correlation and prove that it's 0, you got to use the formula r equals n minus 1, and this symbol that looks like an E is saying to add up all the values of these x minus x hat over the standard deviation of x times y minus y hat over standard deviation of y. So this right here, this part of the equation, is for every single ordered pair in the data table. So if you remember, the data table is right here. So for example, this part right here, for each one it's negative 5 and 0. So r equals 1 over n, which is the number of values in the data table, which in this case is 5 x's and 5 y's, so 5 minus 1, and then you add up, this is like adding symbol, each ordered pair. So x is just the observation, which is negative 5 for this case, for the first ordered pair. Then you subtract it by the mean of the x values, which is negative 5 plus negative 3 plus 0 plus 3 plus 5 divided by 5. That's how you find the mean. So in this case, the mean would be 0 for the x values. So it's 5 minus 0 over the standard deviation of x, which can be found in stat, and then you scroll to calc and find 1-var stats, and it's the SX, which is the standard deviation of the x values. Make sure you're on list 1. So in this case, the standard deviation is 4.12. And then for the y value, you do the observation, which for this case would be 0, minus the mean, which is 0 plus 4 plus 5 plus 4 plus 0, which is the y values right here. And you divide by 5 because that's the number of values, and the mean you get is 2.6, and you divide that by the standard deviation, which is found by going to stat on your calculator, going to calc 1-var stats again, but instead of list 1, it's list 2 for the y values. So you'd find the standard deviation to be 2.4. So then that's just for the first ordered pair, and you're supposed to do that for every single one and add each different ordered pair. So the final equation would look like this once you did all the math. So here's the final equation right here. It's r equals 1 over the 5 values minus 1, which is 1/4. And then each one of these ordered pairs right here is found from doing the x value observation minus the mean of the x values over the standard deviation of x, and the y is found by the y observation, which is the point in the table that you're trying to get, minus the mean of the y values over the standard deviation of the y values, plus the next ordered pair, which is negative 3, 4. It's negative 3 as the x observation, minus 0 again, which is the mean of the x values over the standard deviation of the x values, which is 4.12 again. And the 4 from the y values is here as the observation, and that's subtracted by negative 2.6, which is subtracted by 2.6, which is the mean over the standard deviation of the y values, and you do that for every single ordered pair. And when you plug that whole thing into your calculator, you should get your r value to equal 0, which proves that the correlation is in fact 0. For part C, it asks you to tell why the scatter plot still shows association even though the r value is 0. And the reason for this is the graph's form isn't linear like this. It's actually quadratic, which shows that there's no correlation because the points are all randomly scattered like this.